Hello, testing, testing. All right. Can you guys hear me now? Just give me a thumbs up in the chat. Okay, there we go. So usually when I start going live, I ask, "Can you guys hear me?" And you always say yes. So I didn't bother this time, but there we go. So let me do that introduction again before I bring our guest on. Hello and welcome back to the live stream. It's been quite a while. We have a repeat guest today. He is Donald, also known as the Packet Thrower. He's a very experienced network IT guy in general. I'd say definitely an expert in networking. He's got every certification you can imagine. Not all of them, but plenty, of course. And this is his third appearance on the stream. He taught us some Aruba, some automation in previous streams, and today we're going to learn about wireless. So that's what we're covering in my course at the moment. So I think it will be a good thing to get another perspective on that. And he's more of an expert in this stuff than I am, so I think he'll be able to teach you a lot of stuff that I haven't mentioned in my course. So I think we are ready to get Donald on. Give me a second. Let me change scenes here. All right, Donald.
Well, hello.
All right, you're on. Everyone, let me know if you can hear Donald. Just say something again. Looks good on my end. Okay. So Donald, how have you been?
Living the dream.
Living the dream. Awesome. Yep. Sounds good. What are you working on these days, or what are you studying?
Buried in projects, doing everything from wireless, appropriately enough, to some automation and SDN stuff. I'm always into something fun.
Yeah, yeah. Sounds good. Cool. That's a nice Cisco shirt. How'd you get that one?
I don't remember actually. I normally like to wear the opposite vendor I'm talking about just for fun there, but I wore my Fortinet shirt yesterday and I didn't feel like washing it, so I figured out where this one. I can't remember where I actually got this one.
Cool, cool, cool. All right. So, what are you going to be showing us today?
Well, I figured we'll cover some of the basic CCNA level wireless stuff that's good to know there, and then we'll probably go a bit further like we always end up doing. And then we'll basically just focus on the WLC, but we'll talk about what else is out there, and depending on how much time we have, we could venture on other products, or we'll just pick it up next time. But it's a big topic, and it's a lot of things to cover and stuff, but it should be fun.
Cool, cool. Do you have a lot of experience with Cisco Wireless in your career?
Oh yeah, I've been using it for far too long. But yeah, I do a lot of Cisco Wireless there, from small sites up to like tens of thousands of access points.
Yeah, yeah.
And then the newer platforms, I work with them a lot, and their side companies like Meraki and whatnot. So wireless is always good there because one of my specializations is Cisco Weiss, which is
Oh, yeah.
their security framework product, and I like and usually you want to integrate ICE with your wireless and as phase one, and it's so if you work anywhere in Cisco security, you're going to get dragged into wireless one way or another.
Yeah, yeah, for sure. All right, cool. You ready to get into it?
Yeah, I
Sure.
guess we'll just share my screen.
Yep, share screen. Hey, everyone in the chat, thanks for joining. We got people from all over the world. All right, I'll get your screen up there.
Hey,
All right, your full screen. Good to go.
so look good?
Yep,
Cool.
Wi-Fi stuff.
Wi-Fi stuff. All right, so we'll just cover a bit of the basics there. I don't want to drown you guys in too much fury, and then we'll dive into the fun stuff. So you said you're doing a course right now, Jeremy. Where are you at that? Or where are you in that?
Oh, so I've finished all of the CCNA wireless topics on the course on Teachable, but on YouTube, I've covered everything except actually configuring in the WLC itself.
Okay, well, I'll just blaze through the couple. So yeah, well, maybe I'll just skip it. So you talked about like the wireless standards, like what 11AX is and that kind of thing.
Yeah, in general. You can go over it briefly if you want.
I'll just do it quickly there. So there's been quite a few standards over the years. When we first started wireless back in the day, we had 802.11 as the original, and then eventually that became the first practical standard was 11B, and this gave us a whopping 11 megabytes per second. And when you talk wireless speeds, you can always cut that in half there because it's half duplex communication. So that's about 6 megabytes per second. So typically we don't want to use that kind of speed these days there, but you might encounter it in the wild. Then we had 11A, and this always irritated me how B became before A, but that's what they did. And this one gave us 54 megabytes per second. And particularly, this let us work with the 5 gigahertz range. And then the next thing to come around was 11G. And this was also 54 megabytes per second. But the benefit here is that this used the 2.4 gigahertz range. And this is what your common devices use there. So this was more about bringing backwards compatibility to everything there, so that everything would. Now the bad thing about 2.4 gigahertz range is that because everything's on it there, that's where you can have like your microwave break your wireless there. If you're cooking dinner and you're wondering why the Netflix stops working, is because you're on 2.4 gigahertz, and the microwave happens to also be in that range. So there's a lot of interference. So typically you always want to stay with the 5 gigahertz ranges if you can help it. Then we had N, and this was a big deal back in the day. This gave us 600 megabytes. And this worked by doing something called MIMO. And the idea here is that it basically sent multiple streams for all the different antennas there, and it took advantage of physics there where it actually bounces signals off walls and whatnot. And when you scatter the signals, it actually gets arrives relatively at the same time there. So with that shenanigans, they got a lot more bandwidth than we ever seen before. And then that carried on into AC. And this gave us two different choices because this actually used both bands there. The 5 gigahertz gave us about 1300 MPS. And then for the 5 gig, and then for the 2.4, it gave us about, what was it, about 450 or so, something like that. 400, and it's mostly for backwards compatibility and also for doing some more advanced functions. But is there anything interesting about the 1300 number that might jump out at you, Jeremy?
Something interesting about 1300, not off the top of my head.
A link speed.
Sorry, what's that?
Well, for your internet, we don't usually have 1300 megabyte interfaces on our switches, right? We have 1 gig or we have 10 gig.
Oh, right. Yeah.
So to get around these faster internets or faster bandwidth requirements there, the industry, Cisco in particular, started creating something called multi-gigabit or M-gig. Oh, my.
You're writing with arrows.
Pen is completely failing there. Oh, it's drawing little arrows on it. What is it doing? Boomerang in real time here. Let's try that again. M-gig.
There we go.
There we go. No arrows. I guess this is an arrow. But, and the idea here is that through some software changes on the switches, or just buying new hardware, you could increase the speed of your uplinks for your access points without having to do new cable runs, because it's generally easier to buy a new Cisco switch than it is to rewire your office because you want to put fiber instead, right?
Right.
So this gave us 2.5 gigs, and it also down the line gave us 5 gigs too. Gig, can't write today. That's my Canadian education at work there. Gigs. So this gave us faster speeds there. So if you ever see a modern switch there, it's not out of line to see like a 2.5 gigabyte or gigabit interface or that kind of thing there. So if you're in the real world, don't let that scare you. And the last one we're on right now is 11AX. And this is basically a 10 gig standard, and this is what we're calling Wi-Fi 6. This is Wi-Fi 5 over here. And that's where we're at today. So that's the boring numbers of there. For the most part, Cisco is not going to waste a question or two making sure you know this there, because I want to focus more on practical questions. Network Plus definitely will hammer you on this kind of stuff there, or the CWNA, which I think you mentioned you're working on. They'll definitely want to make sure you understand these kind of things there, because they're all about testing on standards.
Yep, yep.
So anyway, that's the boring speed stuff. So let's take this into the Cisco perspective. There we go. So Cisco has quite a few options for actually doing wireless. So the simplest option is just to have a standalone access point. Access point here. And we simply just connect our, just call this computer, and it will connect directly to the access point, and we just manage the access point directly with no controllers or anything like that. We call this AAP, which is an autonomous access point, which basically just means it's on its own. And typically, you're never going to want to do this unless like you're a really small office, or it doesn't make sense to do a controller option, because if you have, instead of one AP, you have, let's just say, times 50, you can see how annoying it would be if you have to add a new SSID on 50 access points manually and do all the fine tuning.
Yeah. Is there any like standard recommendation for how many APs you should have before you consider getting a WLC?
Honestly, one in my opinion, but
Okay.
I would say anything more than there's probably best practice paper somewhere there, but I would say if you're more than like 5, then you're pushing it.
Yeah, yeah.
Like the benefits of the controller or similar kind of options that really outweigh any cost of the controller itself.
Right.
So speaking of controller, the next thing we have is the WLC. And what we do here is we have our APs, and then they register to the WLC, which is what the CCNA focuses on. Lost my train of thought there. And how this works is the APs will register through something called a CAPWAP tunnel, which is a really fun word to say. And this is a really long acronym, but essentially what it is it's a specialized GRE tunnel that will tunnel traffic directly to the WLC there. And this lets you do some really flexible designs there, because if we have a mini branch here, let's just draw one out there. So let's just say we have our switch, and let's just say we have our APs. Now, if you wanted to, and let's just say we have our WLC over here, and this is over MPLS or something. Now, WLC. I'm terrible drawing today. I guess I'm always terrible drawing, but there we go. WLC. So basically, if we have our WLC over here, what we can do is we can have our firewall here. And this can go out to the internet. And that means that if we have other branches, like let's say we have another MPLS, and this goes to another switch, and we have another AP, we can have a nice central firewall, and we don't need to worry about the cost associated with adding a firewall to this site there, because we just need to provide the basic connectivity, and then our security is all in one spot, which is nice if you want to do central logging and only have one thing to look at. Now, the other way to go is that Cisco says, okay, well, that's great, but what if you don't want to do that? In which case, you can tell the AP to dump the traffic on the LAN, and then presumably you're going to have your own firewall here and your own internet connection. And the logic here is that you don't want the traffic to be able, or if they're in, say, Tokyo, you're in Tokyo right now, right?
Yeah,
Japan?
near Tokyo.
Yeah, fair enough. But if you're in Japan and the central office is in Toronto or some other big city across the world, then it doesn't make sense to backhaul that traffic all the way over there if you just want to dump off the traffic here and just make sure that it gets offline, especially if it's guest internet, you don't really care that much about it. So this is where you can have something there, and this is called Flex Connect. And basically everything gets dumped directly at the AP there, except for some control traffic so that the WLC can still boss the AP around. Clear response so far?
Yep, looks good. If you guys have any questions while Don's explaining, feel free to put them in the chat.
So some stuff that the CCNA doesn't cover is there's actually more options than that. So the next option is a company that Cisco bought, then that's called Meraki. And the idea here is everything is cloud managed. So you log into your controller and you can, in the cloud, and you can administer your network, most of your access points, your switches, your firewalls, video cameras, whatever you have for Meraki. And you can do it anywhere in the world, which is a nice feature. And because the controller's in the cloud there, you don't need, you just send the APs where they need to go and they register themselves and they download their policy. So this is a nice option for lower skilled IT shops there or branches that you don't really care about, but they don't have the bells and whistles of the WLC or the other options that we'll talk about today. The other way we can go is there is, if you have some switches like a 3850 or whatnot, you can get a wireless controller at switch or something. If you have a switch, you can actually have that be your controller instead, and that's what they call Mobility Express. And this lets you manage things differently from the WLC there, but it's its own thing. And you can actually convert APs to be its own controller. And this is kind of similar to the Aruba way of doing virtual access points and having them be managed in a virtual cluster. So yeah, some neat stuff, but you don't really like, this option is not the greatest in the world just because it's a little bit different from everything else. The last option that we'll talk about very briefly is the new way of doing things, and that is the Cisco 9800. Now this is the new controller. Now the benefit of this is that the WLC doesn't run iOS. It actually runs an operating system called ARP OS. And when we get into the command line in a couple minutes, it's very different from what you would expect when you configure a router. But the 9800s are, because they're converted over to iOS XE, you can manage things with standard commands, and it also brings features that the iOS naturally brings you there. So if you want to do things like a DM VPN or an IPsec tunnel or that kind of thing, then you can do that directly from 9800. And the other benefit there is that the 9800 is actually a layer 3 controller because it supports routing, whereas the WLC is a layer 2 controller, which means that it can't really do any routing there, so you have to rely on your switches and whatnot to do things.
Cool, cool. I wasn't aware of the 9800 moving over to
Yeah.
iOS. Cool.
Yeah, it's a new kit in town. They're pretty slick. I don't know if we'll get to it today, but if we continue this down the road, I'm sure we'll talk about it. But you can do basically everything on the WLC, and obviously in a newer, fancier way of doing it. All right, so that's the boring stuff out of the way, I think. So let's get to the fun stuff. Oh, two more things to level set before we get into the fun stuff. I lied to you. All right. One last thing to bring up is the WLC has two options. We have physical appliances, which is what I'm going to be working with. And there's also a virtual option. Now, the physical can basically do everything, so I'll just give that a little asterisk. The physical is better if you want to do a lab or whatnot, but it's not really practical if someone just wants to learn how to do this and they don't want to have to go on eBay and buy a controller and access points. It's probably a bit much for the CCNA. But the virtual option is a free download. You can go to Cisco and download it without a support contract. They have a free trial version. But the catch is it doesn't support the CapWap tunnels. It supports the Flex Connect I mentioned there, where you dump the traffic locally. And the reason for that is that basically because it's a virtual machine, they didn't want to deal with how to dump traffic to a virtual machine, so that's going to left that feature off. So you must do Flex Connect if you're doing the virtual. The 9800 is also has a virtual option that actually does support everything. So when you get deeper into doing like your CCNP wireless, well, that's enterprise now, or your CCIE wireless, you can play with that kind of stuff there. But for the most part, the WLC is fine, and you can play around with it. Packet Tracer also has some support with it there, but to be honest, it kind of sucks.
Yeah, it's very limited.
Yeah, but it's more of a better than nothing kind of thing.
Yeah, yeah.
All right. Now with that out of the way, let's get to the good stuff. So what I've done is I have factory defaulted one of my controllers. So this is the setup there. Does that look okay to you?
Yep, perfect. Yep.
Cool. All right, so we're going to give this a name. I'm just going to call this WLC02. And we need a username, and it's going to use admin. Give the password. Now the service interface is a little bit hard to explain, but essentially what it is have you taught people what a VRF is in your course?
No, I haven't.
Okay, so in networking, you have a concept of a virtual routing and forwarding instance, which essentially means that you can have a separate routing table for, say, do management traffic or some more advanced routing. The service instance is kind of like a first kick of the can at that there without it actually being that feature. So what you can do is you can use this to add static routes so that you can manage your WLC there, but it doesn't support default routing, so it's kind of annoying to use. So for the most part, you can ignore the service interface, especially if you're on CCNA level. Typically just leave it at DHCP or give it a different subnet. Now this subnet has to be different than your management subnet. So just make sure you don't cause any issues there. So let's leave it at that. Link aggregation we'll talk about in a minute. So I'm just going to leave that at no. We're going to give this a management address. And for my lab, I'm going to do 10.30.10.221. 222. Sure. Go to network mask, give it a default gateway. So here is where you have your first major decision. So if you want to have your WLC run as an access port, you can leave this as 0, means that you're not going to take the traffic. And if we look at my switch here, I basically just left it in access port mode there, but if you wanted to get more creative, you can make this a trunk. So what I'm going to do is actually just make this a trunk, and I'm going to say that I'm going to tag VLAN 310, which is what my management VLAN is for my network. Now we need to tell it what port to use. In my lab, I'm just going to use 1. Basically, this is what interface you're using as your management interface. Now it's going to ask you for the DHCP address there because it needs to know where it's going to forward any DHCP requests there. So my DHCP server in this scenario is just going to be 10.1. Now you can enable high availability. We'll talk about it later if there's time, but for the most part, you can run a second WLC there and have it fail over if you need extra redundancy. So we're just going to say no to that. Now the virtual gateway address, this is if you wanted to do web portals. So it redirects traffic to the controller so that you can have the user sign in. Most people don't do this because usually if you're going to do that, you're going to use something like Cisco ICE rather than the controller itself, but it does exist. Now, the common IP address that we used to use is 1.1.1.1, but then a certain company called Cloudflare decided that, hey, that'd be a great IP address for a DNS server. So we don't use that anymore because that can cause some headaches. So our new favorite IP is 192.0.2.1. And this is kind of the agreed standard as a non-routable address that we can use for wireless redirections.
Got a quick question. Do we need a DHCP server for the configuration?
It's going to ask you for one. You don't need one, but it's going to force you to enter one.
Okay. Got it.
So the next thing to talk about is the mobility group. And the way to explain this is that you can have a bunch of WLCs work together and they can share state information. So the idea is that if you connect to one controller and you need to fill over to the other one there, all that session information can be learned automatically to the new controller there. So you can have users like switch controllers without having to re-authenticate or that kind of thing. You need to give it a name, so I'm just going to call this the packet core RF3. Now, annoying thing about the wizard is it's going to make us create an SSID, so we're just going to blow through this there, and then we'll delete it afterwards, and then we'll do this properly when we get into it. So I'm going to call this test. We're just going to basically say yes to everything, but do not hit enter accidentally because it's going to force you to configure radius, and that's just extra setup time if you're not actually going to do that. So we're just going to say no for right now. If we talk about radius later, we will. But for country code, we enter in the country code. You can type help if you want, but I'm in Canada, so that's going to be CA. And then it's going to ask us which networks it wants to enable. So basically, these are the stuff I was talking about before. Now, you notice how this doesn't mention like AX or anything like that there, and partly that's because I'm on older code because I'm using older APs. But you could use in newer code, it might ask you different options there. But for the most part, you're probably on the 9800 if you're doing the really fast networks these days. NTP, so we're just going to go ahead and enter my NTP server. It's going to ask a polling interval. 3600 seconds is a decent standard. Basically, it's the lowest value. IP version 6, it's going to want to do by default. I'm just going to say no. You can choose to do it there. There are some consequences if you use IP version 6 for certain interfaces, but we'll talk about those later on. And with that, we can go ahead and say yes.
Cool. Do you have to go through this CLI setup when setting up the WLC, or is there like a default IP address you can use to just log in straight to the
No,
server?
you have to go for this when you like first take out of the box, like it's
Okay.
your console stuff.
Yeah. Yeah. Got it.
In fact, this is a console connection that I'm doing.
Hmm. Right.
I have this actually connected to an old iMac that I don't really have another use for there, so I plugged some console connections into it.
Cool.
So to save us some time, we're just going to turn our attention over to the other WLC I have. And actually, I'm gonna lie to you, and instead we're going to talk about APs. Plot twist. So we'll shut down the APs. So I have a bunch of APs here. And essentially all I'm doing is just putting the AP on the I'm just putting this on a management VLAN for the APs. So if we go here, I can type, I swear. There we go. So this is basically just an SVI created just for this there. And this is literally just an IP address, and I've added this to my routing for my network, OSPF, and that's all we've basically done. And then I do have some PHP set up already. And what I'm actually going to do is just delete it. All right. So what we're going to say is IP DHCP. I'm going to say that the network is 120, and then we can enter our subnet mask, or if you want to, you can actually do /24. One of the few parts in iOS you can do that. Default router is going to be 1020.1. But I will say one good thing about wireless is that it does force you to work with some of these other features like DHCP or whatnot there. So you get pretty good at the more the features that you otherwise wouldn't really touch too much, because usually you do like Windows DHCP server, that kind of thing. And we can actually do Windows or Linux or for DHCP. It's just since we're focusing on CCNA kind of, it's better to do it on the router. So there's a couple different ways that we can get the access points connected. So what we're going to do is I'm just going to leave it at this, and we're going to look at a manual way of registering the AP, and then we'll look at the other two methods that we can do.
Sure. Sure. Just another quick question, not necessarily related to wireless. It says,
Sure.
just a silly question, but I want to know how he has the colors in the CLI. It's easier to read that way. How do you get that set up?
Yeah, I get that question a lot, actually. In fact, did we talk about this last time? I'm pretty sure we went into it at one point.
Did we? Maybe. We might have.
Whatever. I'm here. So what you do in Secure CRT is the reference that I started with is you can download it to search for Google Words for black background. This is basically just a series of regexes there. I've heavily customized this over the time there, so I don't really know where the original file starts and mine ends, but basically you add your regexes to basically say like, hey, if you see a MAC address, I want it to be this color. And so this is a good time saving method, but that's the thing I use.
Yeah, yeah. So yeah, get Secure CRT, this terminal program, and then look for those Cisco words for black background, and you can get these
Yeah,
colors.
I mean there might be better ones, but this is the one I've used, and I don't know, it's part of me now. Anyway, what we're going to do is we're going to just go ahead and start up our APs here. And we're going to go to console connection for an access point. And if you're curious, it's just a Mac Mini I have with some console connections into it. And I just use screen to connect.
Nice, nice. I've never actually set up an AP through the console.
That should be fun. Basically, we just wait, and it's going to take a minute to boot. Is there any questions so far? Got some time to kill.
No additional ones at the moment.
Cool.
I did have to do a lot of. I bought a few APs and an old wireless LAN controller to make my videos for the course, and getting the APs to join with the controller took quite a bit of troubleshooting because I put in the wrong country code for the wireless LAN controller, and they wouldn't join. And then the certificate date was wrong, so they wouldn't join. And I do a lot of debugs to work that out.
Sometimes. Looks like it is almost there. At least relatively quick there, because you will be rebooting APs a lot when you're studying. So when you log in, it's Cisco, capital C. And this is... There. So this is has some iOS commands there, but it's not really iOS. It's its own way of doing things. So most of the commands we're going to be dealing with these days is capwap. And then there's a bunch of commands there that deal with getting it on the controller. If you have a really old AP, then there is the LWAP, which is the predecessor to capwap. And basically, you have the same commands there, but for the most part, you're always going to use capwap for this kind of stuff. Looks like that's actually... Oh, it remembered it from my previous attempt. Oops. But what you would do if you wanted to do this manually is you go capwap AP, and then you would first want to make sure there's an IP address there, and if you want to do a static IP, you can. So you can say IP address, you can give it IP, and then you can give it a default gateway if you want a static AP. Typically, you just let DHCP do its thing there, but sometimes you just want to have administrative control over what's what. The actual command we want to do is capwap AP controller, and then we say IP address, and you manually tell it the controller IP, and this is going to tell it to start the capwap connection. Now, this actually remembered my previous setting up there, so you can, if I scroll up, you can see that it actually connected the capwap tunnel, and it uses port 5246. Now, you don't really need to know this for CCNA or whatnot, but if you're more advanced, then it's useful to know. And you can see it joins the request, and if we were to log into our controller here, you can see that a bunch of APs have registered, and it's mostly just because I didn't bother factory defaulting them, but they would show up here. Now, the other ways we can register things. Where's my secure CRT? There it is. The other way we can do this is we can go back to our switch, 350 here. And we're just going to go back to our DHCP. Now, the other way we can do this is we can do option 43, which is where we give it the controller in hex format so that it knows how to reach it. So what this looks like is my controller, just for everyone's reference, is 10.30.10.210. So what we're going to say is option 43 and hex, and we will give it the hex. Now, this is always going to be F1. And then this is going to be either 04 or 08. So basically what this means is how many controllers you have. If it's 4, that means you have 1 controller. If you wanted to give it 2 controllers, and you would set this to 8, and you would add both hexes there. So 10 would be 0A, and then 30 would be 14.
So 1E, 16 plus 14, 1E.
What's that?
Would that be? Oh, I see. 14. I'm just doing the hex calculations in my head. Not very good at it.
Let's double check it there. Maybe I made a typo. All right. So if you guys are curious about how to do hex and you are just doing it on your lab, you don't need it for the test, you can go ahead and open up a calculator. Close, there we go. And you want to go to programmer mode. And 30 would be, oh, it is 1E. Oops.
Oh, there we go. Got it.
So there we're doing it live.
Yeah.
All right, so then
live math is never a good idea.
Yeah. So 10 again, and then 210.
210. I have no idea.
Oh, we already broke out the calculator. There's no shame now. 210 is going to be D2.
D2. Nice.
All right. So what we have here is F1 always. 04 means 1 MAC address, or one WLC. And then this is our IP address converted. Now, if we wanted 2 controllers, we would just set this to 8, and then we would, right after the 2 here, we would just go ahead and enter the second IP address. We'll go ahead and do that. Now, I'm not going to bother actually, well, yeah, we're here, so let's repeat it. 8, let's say shut. When this comes back up, it should learn that from the DHP options.
So waiting for the APs to come back online.
Yeah. Oh, by the way, while we're waiting here, the APs are automatically going to download the firmware from the controller when it gets registered there. So when you upgrade the controller to a new version, that's going to cause all your access points to automatically upgrade there because everything's going to be on the same code point. So there's some complexity there of how you want to handle it there, but for the most part, when you update your controller, you're updating your entire wireless environment there. They don't want to have a situation in any real vendor that will let you have the controller and the APs be different versions because of the way things work. So you don't want to upgrade your WLC and cause an outage there unless you're expecting one.
Is there any way to upgrade the WLC without causing an outage, or?
No, basically what you would do is you would fail over the APs over to another WLC that is on the version you want.
Okay.
And then when you're ready, you would like move them in controlled fashion.
Yeah.
We'll give this a minute. So there you go. See, controller address learned through DHP. So looks like I didn't mess up any more hex codes. So good to go there. So there's one last option, and you can actually see it here. Is trying to resolve this name there. So we'll do a DNS lookup for the controller, and most people tend to prefer this method there just so they don't have to deal with hex. So they would enter in this name. So what we would do is we'll go back over to our 3650 here. Now, first, you need to give it a domain name so it resolves things properly. Then we need to give it actual DNS service to query. That's going to be DNS servers. And now we actually need to add that entry. So if we go to, do I have it open already? Let's see. I do. Okay. Let's just, yeah, that's clear. So I actually already have this entry here, but oh, it's the wrong IP. Oops. So must be an overlap. So this is Windows Admin Center. If you haven't seen it there, this is kind of the new way of administering your Windows environment. And this connects to my domain controller, and I can do my DNS stuff. So all I do here is update my DNS record to be 10.30.210 because I already have Cisco-capweb-controller. And go save. And we're not going to bother because it's basically the same kind of thing, except for it's going to say it's going to resolve the name for the record. But as long as you have the domain name, that's the main thing there, because otherwise it's not going to know which DNS server to query, unless you have like a root level kind of thing, which is kind of rare. So you always want to set your domain name if you're doing that option there, and of course you need reachable DNS servers for your APs. So anyway, that's our APs registered. Questions about that so far?
Nothing in the chat at the moment.
Yep. All right, so let me get fully out of this logout. All right, so when you first log into the WLC, Cisco gives you this nice little GUI kind of thing there, but this is all smoke and mirrors to help you monitor things. If you actually want to configure things, you have to go to Advanced, and then you get the classic WLC information. So inside here, we can see that I'm running this code version, and that apparently I have a really low backup image on here. And we can see I have 5 APs registered right now, and you can see they're running different radios for the version there, so they support and that kind of thing. And we can see we have no clients because we haven't got that far. So what we're going to do is we're just going to go to WLAN, and we're going to delete that temp one that we had to make.
Yeah, this is the default one you had to make in the CLI setup, right?
Yep. Yeah. Now, obviously, if you're doing a simple setup there, and you have all the information, you can just go ahead and enter your SSID. But for the most part, it's better to just do it from the GUI properly. So let's just go to controller first. And first of all, we're just going to give this a host name. So we can see we can give it a host name. We can see that we can adjust some settings on the routings and how things are working. The big thing is lags. So right now I'm only using, I'll apply that so I don't forget. But if we go back to our interfaces here, monitor me, you can see that I'm using only the first interface. But if I wanted to use multiple interfaces in the port channel, we have to reboot the controller for that. So we have to go to controller, and we have to enable this. Now this is one of the more annoying things about the WLC is it doesn't support LACP. So that means that you have to do channel group on. I don't know if you ever talked about that in your course, but it's not the greatest thing in the world because it's kind of like statically forcing a port channel that can cause some issues. Just one of those things there where Cisco's disinclined to change because people are so used to it at this point, and they have the new controllers out now, so I'll just tell you to buy that if it really bothers you.
Is that the case also for the newer like 9800s?
No, that supports LACP and PEGP and all.
Okay.
Basically, anything that a Cisco switch or router can do, it can mostly do.
Okay, nice, nice.
So I'll give this a DNS server 2. We don't really need it, but we'll add it. Oh, swamp. All right, so that is the basic settings for that. Now, there's a bunch of interface names that we need to be aware of. So we go to interfaces. The management interface is, as you might expect, the management interface. So this is where we actually administer things. And this has something called dynamic AP management enabled. And what this means is this is the interface that APs register to. If you want to, you can have a dedicated one just for registering there, and you can have a separate for your management one. But for the most part, in small environments, it's fine to use the management interface to register. Redundancy, management and port, this is your HA stuff. So if you want to have multiple WLCs run in high availability mode, that's what you would set up here. You add your IP addresses, and then you would do your peering down here. The service port, we talked about that before. This is a port that lets you have some extra management, but you can only do static routes. If you click here, you can see that there's no default gateway. So what you would have to do is you would set the IP address, and then you would set static routes to say, like, hey, my management network is this, and it's generally much more of a pain than I would like, so I tend to avoid it unless there's a really good reason to use it. And then we have the virtual interface, which we briefly talked about, and this is really just used for redirection stuff. Now, the other way we can go is we can, actually, you know what? First, I'm going to say this is a trunk, because right now this is an access port. And we can see we can do things like NAT and whatnot if we want to. We can have some control over which interfaces are being used, and if we want a backup port so that it only comes up when the other one's down. And we can do things like add ACLs for access, that kind of thing there. But for the most part, that's good. So we're just going to turn this into a trunk port, essentially. So I'm going to go apply, and I'm going to lose access because I set this up as an access port. So we're going to go over to my switch, which is rater. Switch. By the way, this does support WLC. Oh, wrong switch. This does support CDP, so you can see where your controllers are for administrative stuff. So we're just going to say that this is switch port VLAN, switch port mode trunk. Oh yeah, it's another switch. If you guys don't know, on the newer switches, you don't have to do the .1Q encapsulation because they removed the other one. So you just do switch port mode trunk. So switch port mode trunk. And with that, because it's just a WLC, I'm going to say that we're just going to say that we're going to enable port pass for the trunk so that it doesn't cause any issues with our forwarding. So if I've done that right, I should have access to my WLC again in a minute.
Oh, there we go.
But you can see I've lost my APs. They'll pop back up in a minute, hopefully. And if not, there'll be troubleshooting. So anyway, that is the basics of that. So now what we have it in trunk mode, we can add extra interfaces. So what's common is you might want to have your SSIDs run in particular VLANs. So you might have like a guest VLAN and enterprise wireless VLAN. So if we look at my switch, this one, I have these three SPIs. That doesn't matter. My network, I can do that. All right, so we're going to say that 151 is going to be our guest network. And then 152, when we get there, will be our port network, and that's probably enough for what we're doing. All right, so 151 is going to be our guest, and our corporate network, when we get there, is going to be 152. And all we're done here is to add the IPs and add them in the OSPF. So I should be able to add a new interface. And this is called a dynamic interface. So we can name this, say, guest interface or whatever we want to call it. And we're going to say this is 151. Apply. And this is where we can go ahead and configure a bunch of options. There's a ton of stuff here, but for the most part, you can pick if what physical port that's going to be on. So it's going to be port 1, in my case. Now, we can choose to do port channel, but it's not really worth a reboot. And this will be in that subnet, which I had, 31. And we're going to give this 10. Now, you might be tempted to say, like, I'm going to give this .1, but remember the WLC is a layer 2 device there, so it doesn't really have routing capabilities. So we can't advertise this network like we can with the 9800 there. So typically what you do is just give it an IP address on the LAN so it's accessible, and then it will dump out to the switch and do routing from there. DHP information, we can just leave this blank, or we can add it there. I'm just going to go ahead and say that this is 151.1. And we can do some MACL stuff. We can and some more advanced features. We can do IP version 6 if we want to, but we're not going to bother. I'm just going to go OK. Now we have a guest interface, which is here. And then we'll just leave there. Now, I notice how I left the dynamic AP off there because the point of this is not to register APs. This is meant to work for SSIDs. So speaking of that, we'll go to our WLAN. And what we do is create new. And we want to give this a profile name and an SSID. Now, the profile name is how you reference things in the WLC, and the SSID is what you actually connect to. Most of the time, you want to keep these the same just so that you don't confuse yourself. You can choose to have them differently, but I would recommend keeping them the same if you can. So we'll call this guest. And we'll call this Jeremy guest SSID. How's that?
Perfect.
So there's an ID number here, and this is how it's referenced in the system as well when we get into the command line stuff. Now you can see that there's 512 here. So basically, that is your hard limit for how many SSIDs you can have. You're probably not going to have 512 SSIDs in a single SSID. That'd be a little bit obnoxious, but people have done weirder stuff. We're just going to go apply. And this is where we actually start configuring our WLC. So first thing that is of note is that it is going to be disabled by default. So we're just going to go ahead and enable it. It's going to ask us the radio policy. We're not going to get too much into this, but you can fine tune it so that you only have particular radios. Because what you don't want is you don't want someone to be able to connect with wireless B, because that will drag down all your connections for everyone else there, because wireless is kind of like a lowest common denominator kind of thing. So if you don't have need to support legacy clients there, you might force them into the newer stuff. Or just leave it at all there because it's flat. We don't really care. Now, by default, this is going to be the management connection, but you see we have our guest interface. So we're just going to pick that. And what that means is the connections are going to be put in that 151 subnet when we get connected. Broadcast ID. So this is, do we want the access points to advertise the SSID, or do we want it to keep it secret? Most of the time, you always want to keep it broadcasting. The only times you wouldn't broadcast it is you can, when you do corporate SSIDs there, where you're pushing like group policy or whatnot there, and they need certificates and stuff to do it there. It's not really worth advertising, but otherwise, it's not really considered a security feature if you hide your SSID, because anyone worth their salt can figure out their SSID pretty quickly, but it's an option too. NAS ID, so if you want to, you can, when we talk about ICE, if we get there tonight, then this will basically just choose how it identifies itself to the ICE server, but we'll just leave that blank for right now. All right, so the security, we have a bunch of options. So the easiest thing ever is none, which basically just means you press the button, you're instantly connected. Probably not the most secure thing in the world, but there are reasons why you want to do this. And the reason why is if you're doing like a portal authentication, it makes sense that you want them to just connect to the portal and then tell them who you are, or tell you who they are. And then once they're authenticated, they can move on elsewhere. But for the most part, obviously, if you're doing corporate internet and you want to put a password or something on it. So to that end, we have WPA and WPA2. Now, there's a bunch of options here that are really more about fine-tuning. So you can see like what encryption you're going to be using. Do you want WPA 1 or 2? Typically, you're always going to use 2 these days. We're at WPA 3 now on newer code, but my controller doesn't really support it. My 9800 does, but not my WLC. So then we tell it how we are going to authenticate. So 802.1x is ICE. We'll maybe talk about that later. What we want is PSK. So this is where we can go ahead and enter in a password for SSID. And this is what most people are familiar with when they connect to wireless. They have a key that they enter. So I'm just going to enter a simple password that I won't forget. Then there's some other options that are more for higher bandwidth uses and whatnot there, but we're just going to keep it simple for right now. So PSK. Now, if we want to do layer 3, this is if we want to do portals. Now, typically, you're never going to do this there. You're going to use a server instead of the built-in WLC, but you can. And AAA stuff we'll talk about when we do the corporate one. QoS, you can, Cisco does want you to be a little bit aware of this. So basically, the main things to know there is, as long as you know the main things there, silver is best effort, gold is video, voice traffic is considered platinum, and bronze is background traffic. So that's kind of stuff that you don't really care too much about. So you might be inclined to put like your guest wireless on a lower QoS there, but for the most part, most people just leave it at silver. You can do application visibility if you want applications to be identified. And if you do that there, you can get deeper into it. We're not going to play with that too much. You can hard limit your wireless there. So if you want it so that everyone gets like 1 megabyte per second for your wireless, you can go ahead and configure these contracts. And there's some integration with Microsoft Link, which is Skype for Business these days. And so that if you're using that product there, it can have some synergy and honor those QoS policies. Make sense so far?
Sounds good.
Did I put everyone to sleep yet?
All awake, all awake. Actually, I do have one question.
Sure.
Going back a little bit in the demonstration, but how do WAPs get registered to the WLC over the WAN if the WLC is located at a remote location? Well, I think you demonstrated that with the DNS entry, right?
Yeah, so you would do that there. There is more advanced kind of um, WLC, or there's a more advanced method there where they can basically VPN back to the controller, but that's another matter. But for the most part, there you would have the DNS entry or the DHCP entry, and then you would you might have to do some NATs or whatnot for it to reach the intended target. But it's really just as long as there's IP connectivity, you can register.
Yeah, yeah.
Policy, we'll skip over this there, but this is if you want to do more granular enforcement of what's allowed and what's not allowed and how to treat traffic. Advanced is, as you might expect, where all the advanced options are. So there's a bunch of stuff here, there, and this will be all day if we talk about all of them. The main ones to talk about for this there is settings for what ICE would do. So we can say like, hey, we want the ICE server to be in control of the session. We can say that you're only allowed to use wireless if you're given a DHCP address there. So what some smart people might do there is they might try and set a static IP address on their wireless there to try and bypass some policies. So this is basically going to say if we do not give you a DHCP address, you're not allowed on the wireless. There's some profiling stuff. Which is the WLC will figure out what kind of device is connecting, and I'll do that from looking at the DHCP and the HTTP traffic that's coming through the wireless. And then when we get to it there's the Flex Connect stuff there. This is where if we want to dump the traffic off to the WAN. And there's a bunch of other settings that we'll just gloss over for right now. So that said, we should be able to apply here. Oh, I'm not doing long enough. I was too insecure. I'm going to use my other password. There we go. All right, so we see this is enabled. And everything is basically just as we just said it. We go to WLAN. You can see that. You can see it's enabled here, and it's good to go. If we wanted to stop it, we would just go in here and we can disable it. We can also delete it if we want to, and there's some more advanced settings that if you wanted to do something like mobility anchor, which is basically if you want to send traffic to a WWLC there, like say you have a WLC connected to like a secure firewall, then you might want to send guest traffic to that particular WLC. Then that's what you can do there. Then there's some more fancy settings there that will be all day if we talk about. So now we have the WLAN. You might be wondering, how's this actually being advertised? And that is done by AP groups. So by default, all WLANs are going to be advertised to all APs. And that's fine for most situations, but if you have it so like particular SSIDs are only meant for certain buildings or certain areas, then you're going to want to build more granular groups there to say that, hey, this third floor building or third floor SSID is going to only be on these particular APs. So you build them out as you need to. So right now our SSID is advertised. So what we can do is go to my virtual Windows 10. This is how I like to lab things there rather than a whole bunch of laptops. And all I do is I have some USB wireless dongles, and we can use that to advertise directly into, or I can share that USB directly with the VM so that my VM can get online.
Oh, cool.
Cause issues. So this is how I do it, like a lot of ICE courses and testing and whatnot in the real world there, rather than plugging in a laptop in my basement and running back and forth.
Mm.
It's easier on the ankles. You know?
Yeah, good setup.
Yeah. So, yeah. We're just going to pick this one and go connect. And if we look at my wireless here, we should eventually see my wireless connection show up. There it is. So I'll make this a little bigger. So if I go connect, let's see, breaking things there. We'll disable that. Cool. So we'll disable our LAN. Okay, there we go. We'll go connect. And if the lab gods are kind to us there, we should see our Jeremy SSID. Oh, you know what? I'm going to turn off the Cisco here because that's a bit more complicated than what we get into right now. Basically, you can use any connect from Cisco there to authenticate to your secure wireless. So I just told it to back off there. So we're just going to go connect.
Oh.
And we see that we have a bunch of... Oh, there we go.
There we go. Got it.
So if I type in my new password, and all right, so I'm connected, but my DHP is not happy.
Yeah.
So just have a quick look here, because I actually don't remember how this is in my lab right now. EU. All this. Yes. Got a busy street there.
Let me turn my mic off. Yeah, there's a fire station nearby, so happens pretty often while I'm recording.
As long as it's not me. All right, so we have our DHP set up. Ping the WLC.
Was it the 3750 connected to the WLC?
Yeah, I just realized that I probably don't have that VLAN
I see, I see.
over here. Yep.
Oh, okay.
So, pro tip, guys, VLANs need to exist. Actually, this will be a little bit better for us. So let's do this. Because we don't need the VLAN on our AP switch because we're tunneling the traffic to the WLC.
Right, right.
So what we're going to do is we're going to say no VLAN, no int VLAN 1.1.3, and then we're going to say I'm going to grab you. I'm going to say no IP DHCP pool. Okay, so it's completely off our access point switch, and we're going to put it all on the WLC switch because that's where the traffic is going to be living for right now. So say 151. BTP. BTP version 3 for you. Let's try that again. Name against wireless. 151. And then we're going to paste in our DHCP. And we're going to. So this is the benefit of labbing all the time there. You get really good at making these ad hoc adjustments when you run into problems. It's good for troubleshooting in the real world too when you get into it.
Yeah, for sure. Practice.
Right. So in theory, that looks better. Now I have to go to ping.
Nice.
All right, let's try that again. So let's go back over to here. Just going to go ahead and disable. Again. All right, so we are connected. We have internet access. And apparently I forgot my exceptions, but whatever. I got .2. Not a big deal. Now, I don't know if I actually have internet set up. Well, I guess I do.
Nice.
So I should be able to go to we can see web page open up. So we're on a line. Now, if we go back to our controller and go monitor, there's actually a couple different views. So the nicest one is if we log out and log back in, we can go back to the new dashboard. There's other ways to get there, but that's the easiest way. And we can see that we have one client connected with 5 gigahertz. And you can see there's a bunch of APs that it sees and a bunch of clients in the area. So if we go clients here, you can see that we have a connection. We can see it doesn't know who it is there because there's no sign-in or anything like that. but you can get some decent ideas about, hey, what APs are near it. So you can see there's a bunch of APs because I got them all like by my feet here. You can see the state of the connection there. So you can see that we have our WLC, we have our CapWap tunnel to the AP. So it's tunneling all that traffic over here. And then we have our wireless connection. So it shows you a nice representation of what's what. We can see we're logging in with a bunch of different settings there. We can do some stuff like ping the client. Figure out a firewall on that. But if it wasn't, you can get more information. You can get some events. You can do some packet captures if you need to do some troubleshooting. So it's a relatively nice interface. It's a little bit dated these days, but it gets the job done. There's also some command line stuff we can do to get more information. Now, if you're not in the new fancy view, the old one has many of the same information, just doesn't look as pretty. So if we go to clients here, you can see that we have Jeremy. We can filter if we need to. So if I have like 10,000 things connected, I can figure out what I'm looking for. We're just going to go here. Now we can see many of the same information, just not quite as nice. But it gets the job done. So that's that. And now if I wanted to, I can kick this person off the wireless. So you might do that if it's a bad client or if it's someone doing something wrong or it's a poor connection, you're just trying to force them to re-authenticate. You can remove the session here and it's basically going to kick them off. And then in Windows case, it'll just connect again unless you do some kind of thing to blacklist them. So that's a basic guest wireless. Let's just turn our attention over to the WLC for a bit, or the access points, because we haven't really spent too much time on it. And once you can see they've automatically registered and everything is default right now. But if we pick on one, like let's say this 3702, we can give this a name so it's more useful. I can say C. Yeah, you can see I've done this before. I'm very predictable in my naming standards, usually thing and number it. But here is where we can get configure the AP for whatever we want. So if I wanted to disable an AP for some reason, I can turn it off, and that's just going to basically stay offline until we do something about it. We can change the mode. So local means CapWap. Flex Connect we talked about a couple times there, and that's how we locally dump the traffic there. So if we wanted our 3850 to have the traffic instead, we would do the Flex Connect, and if there's time, we might look at that. Monitoring is basically all the other ones there are versions. These here are different versions of doing monitors and sniffing traffic and detecting rogues. Like they're just different ways to enhance your monitoring of your wireless. Bridge means that you can mesh access points together. So in the outdoors, in outdoor wireless, you don't always have like a way to connect your access point to like a switch. So what you do instead is you have the wireless connect to each other so that you can extend your connection across buildings or in an oil field or that kind of thing. And then a bunch of other sensors there. Well, CCNA, you're only going to use local. If you choose to do the virtual option, you have to use Flex Connect. And the other ones are really just more if you're doing your CCIE and this kind of stuff, or you're in the real world and you do it. You can set a static IP if you want to. Typically, it's not really worth it unless you're doing this for a lab and you just want things to be predictable, but you can. You can also do some interface configuration if you need to, for if you need to add certain things. You can tell if you want to point to different access point or controllers, you could have them added here or there so the APs know which ones to fall into. Now the failover priority, this has to do with licensing. So if you're only, this controller right now is licensed for 150 access points, but if I have, say this is a failover controller for let's say 500 access points, then if you need to start picking like which AP is more important than others, then you can tell it that, hey, this is the CEO's access point there. So if you need a license, bump off someone else. Inventory basically just tells you what's there and what the capabilities are. And advanced is you can do things like if you have that issue of the country code, you can change it. You can change what groups it's in. You can decide how you're going to connect to the access point if you want to do like Telnet or SSH, that kind of thing. And here's where you can tell it to get firmware updates from other access points if you need to. So anyway, that's all fun and good. So we're just going to go apply here. So it's going to update the configuration, and you can see that now it has a fancy name, so it's easier to reference. That's basically APs. Now there's some global config stuff there. Like I can say that, hey, I want SSH on all my access points. So I'm just going to go ahead and check this, but I don't want Telnet. And it's going to apply for everything. And I can push a bunch of settings down to the APs if I need to. If I want to change the login, I can go ahead and say, here's my default lab password. And now, if I apply this, this is going to get pushed down to all the APs there. So now everything has the same login. Make sense?
Yep, looks good to me.
Okay. Questions so far?
Nope, no new ones at the moment.
Okay. Well, so at this point we walked through the basics of the controller. We did a basic guest wireless, and we have did the APs. So far we're looking pretty good. Now, if we wanted to do something like add an ICE server, we would go to the security tab, and what you would do is that's a nice server. I was playing around, I guess. I'm going to remove that. And what we would do is we would go ahead and enter in our ICE settings. So we would say new. We would give it my IPs, which would be 11.131, I think. One three two. Then we're going to my lab shared secret. Now, here's where you can do a bunch of saves. Now, depending on your version of WLC there, they make it easier in newer versions to do ICE there. So instead of support for COA, which is change of authorization, it'll say like enable for ICE, essentially. We're just going to go ahead and say enabled. What this means is that ICE can tell the WLC to change its session. And we're just going to go apply. And we'll do the same thing for the other one. So that would be 2. And we're going to allow COA. Now we have our Radius servers for our corporate wireless when we get there. Have you talked about Radius yet with your core stuff? Have you got there?
Yeah, briefly. No detail, but just general overview of AAA and Radius TACAX.
Okay. Now we have to do the same thing for the accounting part of AAA. It's going to go ahead and say yes to that. And not smart, I would copy and paste that, but whatever. All right, so we have our AAA set up. Now there's some more stuff there that you can do. By the way, if you're doing a lab, you might want to go down to the self-significant certificates, SSC, and tell it not to do validation. Because when you get a lab, when you get a new controller off eBay or whatever, and you get some APs there, the certificates might not trust each other, and they might be more pain than you're willing to do for a lab there. So, yeah, it might be easier just to turn those features off there so they register properly. But anyway, we'll go back to our WLAN and we'll make one more SSID. I'm just going to call this port. And you can see it's automatically picked 2. If for some reason I wanted this to be 107, I could pick that, but generally just the auto select is fine. Okay. And we're going to enable it. And I forgot to make an interface, so we're going to go back over to controller. And we'll just say port 152. It's going to be sometimes autocorrect is great, and sometimes it's annoying, but that worked out. All right. Port number. All right, so we have our corp. By the way, if you need to, let's just say you're going to have a bunch more guest wireless users than you're used to, and you need more than the /2040 you picked here. You can create multiple dynamic interfaces, and then you can make what's called an interface group, and you can add, say, Jeremy interface group. And what you can do is you can make a bunch of guest access points for different VLANs, and then you can add them together and use that for the WSSID so that they'll load balance the IP addresses they get, and you can add them in different VLANs. And it's a nice alternative rather than just saying, hey, I'm going to do a /20 for my wireless there. You can be you can have the benefits of a smaller network, but add as many as you need to. So if I want to, I could just go add and obviously this makes no sense because I'm adding the corp wireless and the
yeah.
I guess the other that would make sense, but you do like guest 1, 2, 3, whatever you want to do. So that's an option available to you. Anyway, back to here. And so if I go back to this, you can see I can pick that interface group, or we're just going to pick corp, and I should name that interface, but whatever, we don't really care. We're going to enable it. Now you can see by default it wants to do 802.1x there, so you don't need to do anything or too much more. So if we look, we can see that it is already picked for 802.1x. We don't need to make that selection. We do need to go to AAA and tell it which servers to use. So this is where we say that we're going to do our first PSN server and then our second. These are the radius servers for ICE. And for accounting, we're going to do the same thing. So you can see that 1812 is authentication and 1813 is accounting. And there's actually in the newer versions a button there that you check there, and it just says all the best practices for ICE. But this is an older version, and didn't get around to upgrading it, so it is what it is. But what we're going to do is go advanced. And the first thing we want to do is say AAA override. We want to make sure that it is assigned a DHP address. We're also going to make sure profiling is enabled. And the rest is more Flex Connect, and we'll see if we get we can leave that all the same. So it's going to go apply. Fall to your desk there. So that is the WLC side of things. Now, if we actually wanted to make this work, we'd have to log into our ICE server. And what we would do is we would go to our network devices and we would add here. Did I ever talk to you about ICE?
No, I don't think so. Not in a live
Oh,
stream.
well, surprise! I don't want to talk about ICE. So the idea here is we are defining the WLC there, so ICE knows that it's allowed to talk to the server. They're just going to say that it's 10, 30, 10, 210, something like that. Get a model name if we want, WLC. Doesn't matter. Just going to say this is WLC. All right, so what we would do is just say radius. We would give it shared key. So this is when Jeremy talks to you guys about radius stuff, this is what the business end looks like. So you need your shared key to match for things to work. We'll just go submit. Don't need to get too much into this. And then what we would do, see if we have time to do this, is that's right, I rebuilt this server. That's why. So what we would do is we would say port wireless. And just keep things simple, I'm just going to say that we are going to look for connections from our device, which is the WLC here. Yeah, we'll try it. And what we're going to say is wireless. We're going to say that the radius ends with Jeremy port SSID, I think I called it. And then we're just going to go ahead and commit this. A very simple example. We'll see if this works right away or if I need to troubleshoot it. But essentially, we're just saying that the radius is just going to let it on, and it should work without too much hassle. I'm going to make one adjustment here and just say continue, continue. So let's see what this works. Just going to go over to our desktop. Apparently, I'm out of the disk space. Wasn't expecting that one. Okay, just bear with me one sec. There's always something in the lab. Build.
So this desktop VM that you're using for the wireless just ran out of disk space.
Yeah, I'm just figuring out something to delete.
Cool.
There, let's do it. The downside of having like 50,000 VMs on your desktop is they all take lots of disk space for some reason. So when this comes back up, in a perfect world, we should be able to have our corporate wireless working more or less the way it should.
Cool.
And then I think we'll basically just be at a point there we can put a pin in things unless there's questions. But
Sure.
yeah, we'll see how it goes.
Yep. In my video, I showed the pre-shared key setup because that's what they list on the CCNA exam topics. But it's cool to see the the radius .1x setup.
Yeah, well, there's obviously a bunch more that you can go into it, but
Yeah,
it's,
for
for the basics, this is like bare bones. But it is cool to see. Cool as ice, actually. All right, VLAN 152, VLAN quote wireless. VLAN 152.
I'm sure Kelvin would be proud of that pun.
Oh, very much so. Oh, not updates. Okay, that was bad. All right.
All right, moment of truth.
Moment of truth. Let's see how much troubleshooting we need to do. So, got to connect my Wi-Fi thing again. Well, the guest works. All right, we see it. That's fine. Can't connect. All right, so there's always some trouble.
Perfect.
All right, so let's just have a look. Let's go back to our ICE server. All right, so okay. Oh, that's a guest ID. Okay. So, what we're going to do is I'll show you how to do a debug since we're here. So we'll go copy the MAC address. And what you can do is go to WLC. And by the way, we didn't really spend too much time on this there, but the command line for this is much different than what you would expect from an iOS. So it's its own little beast. What we can do is say debug client based on the MAC address. And now what's going to happen when I try and connect is going to give us a bunch of information so we can see what's going on. Let's connect.
Oh, this time it's asking for the username.
I'm just going to go ahead and normally you would do this with certificates and whatnot there. We're just going to power in through here. But if we look, we should see a bunch of stuff on our debug.
Oh, yep.
So if you ever want to see like exactly what it's doing there, you just do your debug client and you can see a bunch of information on what's going on. You can see that that is retransmitting a lot, so it's not looking promising. But it's connected.
Oh, nice.
Okay. I was doubting myself. So you see that, so we are on the corporate wireless. If we look at our ICE server, you can see that we've logged in, and it's a ton of fine tuning there, but you can see that it's connecting. Right now it thinks it's FreeBSD there because of the wireless adapter that's being used there. Eventually it's going to realize it's Windows and update things, but long story short, you can see that ICE has authenticated this user, and you can see that it thinks it's admin because that's what I signed in as. And if we look at the WLC, you can see that it sees that the WLC is admin. It is so it is able to see that information and help you determine what's going on. I go to here, log in again. Pretty dashboard. No, I didn't want to do that. There, that's one. So now I can see that we get a bit more information than we got previously there because of the 802.1x is sharing that with the WLC. So you can see like here's the username there, and that means that if someone says, "Hey, we need you to track down admin and whatnot," you can start doing that with the 802.1x functionality. And basically everything else is largely the same, except for you can see the connection's different and this kind of stuff there, just the type of encryption and that kind of thing. But it's basically how a very, very basic corp wireless works. And that's basically that. We're just under 2 hours. So what I'll quickly do is just quickly show Meraki. There's not a lot to talk about.
Yeah. I work with Meraki. I like it. It's simple, easy to set up, easy to use.
Yeah, it's simple as its strength and weakness.
Yeah. I think that's accurate
It's
statement.
fine for what I like to call low skill IT there. So yeah, that'd be places with like they don't have a big IT team, or they're just not that talented, or Calvin works there. So here's my wireless network at home. So we see I have a bunch of APs everywhere. But what we can do here is you can visit me at 123 Fake Street if you want. But you can get a bunch of analytics and whatnot. So this kind of stuff's nice there. You can see that like Amazon plugs are connected and iPhones and that kind of thing. You can get a bunch of graphs and whatnot. If you want to configure an SSID here, you go to SSID. And then what we would do is, I'll just pick this one. So what we can do here is similar kind of options. So if you learn one wireless, you can take a lot of the principles and use them in the other there, but there's not a lot of synergy. So like typically like Aruba will do things completely differently than Cisco will. So it helps to have the concepts there, but it's kind of hard to like learn Cisco wireless and apply that to something else. But yeah, it's better than nothing. So what we can do here is open means no password or no password. So this is the non-encryption. New version. Yes, I do want to see a new version. Anyway, so pre-share key. This is where we type in a password like we've been doing in the guest. We can do Mac-based control. So basically, we query the Radius server and it makes a determination, but there's no password. We can do 802.1x with Meraki, or you can define your own ICE server if you need to. They do have ICE integration itself, so you can. Oh, do they hide it on a new page? They did. Oh no, it's here. Cisco Voice. Anyway, so you can choose how you want to authenticate. You can pick your encryption stuff for what's your equipment supports, mandatory DHCP, just like Cisco. You can choose if you want to have like a portal. So if you want to pop up and say, hey, you need to sign in or do something there, you can do that. You can point it to ICE server directly. But yeah, it's nice and easy point and click there. A lot of that, it has a lot of complexity in the options, but the actually setting up isn't difficult. And if you want to do the AP side, you can go over to radio settings. This is where we can make profiles that say like how the APs are going to perform with different bands and what wireless to support. You can also have a look at how big, like you can see that this is a pretty busy channel apparently. But click on this guy. We can get a RF representation of what's going on in my bedroom, which sounds fun. From my wireless perspective. But yeah, so this kind of stuff you would do in the job there, not specifically use this tool, but you would use like spectrum analyzers to see like, okay, well, is there interference we're not aware of? And this is will help you pick which channels to use. So as I mentioned, 2.4 is very busy. As you can see, that's pretty hectic there, but 5 gigahertz is going to be a lot cleaner. So yeah, that's basically Meraki in a nutshell. There's not too much to it, so it's definitely easier than the WLC. And but when you need the extra features, it's not always there, so it's always a trade-off. Anyway, I think that is pretty much everyone I was going to cover. Did you have any questions queued up before we start wrapping this up?
Nope. I think we can start wrapping it up. So regarding Meraki, would you say it's appropriate for like smaller companies who can't really afford to hire like experts, IT staff, or something like that?
Yeah, I mean the point of Meraki is that you would you can make your access points, and they would just magically show up on your account when you, assuming you pre-register them, and then it's easy to adjust things there. Like if I wanted to adjust this wireless, like I can rename it. It's very simple. There's not like a bunch of layer stuff there. I didn't talk about like Flex Connector there, but when you start getting in that kind of stuff, it's the WLC can get pretty daunting.
Right.
So it's definitely easy to just click your way to happiness. Like if you wanted to add a radius server, just click it and you can test it out real quick. If you want VLAN tagging, you just pick the box, and it's a nice product. It's just when you compare it to the more enterprise solutions, it's not meant to compete with Cisco or Aruba or that kind of stuff there. But if you're talking about like the lower grade stuff, like Ubiquity and that kind of thing there, then Meraki is a pretty good option. Or Ruckus or one of the smaller guys.
Yeah.
Yeah, that's Meraki in a nutshell. I got switch stuff there too, so you can add your You can control your network the same way there. So you can see there's an AP connected to this, or was. So if I want this to be a trunk port, I say a trunk. One interesting thing about Meraki there is that it actually has all VLANs defined at all times there. So you don't actually have to add VLANs. It's just
Okay. Cool.
everything just passes through the Meraki. But yeah, it's good up to a point. Now I have done some enterprise grade Meraki implementations there, and that's like hit your head against the wall. If you try and use Meraki above its what it's good for there, you're gonna really hate your life. But you're a small IT shop and you just need a branch, or you're like a retail chain and you just want like a simple setup there where it's standardized, and you can't go wrong with Meraki too much.
Nice. Cool.
Alrighty, any questions and stuff? Or
Nope. So to summarize, we covered some Wi-Fi basics at the beginning. Jumped into the WLC. We did the PSK configuration of the guest WLAN. Then we did the .1x with the ICE AAA server for the Corp WLAN, and then took a brief look at Meraki. Pretty much covered generally what we need for the CCNA. What would you say that people need to know about wireless? What should they focus on for just the CCNA exam? Which aspects?
for one, Cisco isn't kidding. They want you to know how to configure the basic SSID. So once again, just real quick, you look through it. They want you to basically do basically all these options, except for policy mapping and advanced. So the first three tabs you should be familiar with. Actually, general for sure. Security, it's really just pre-share keys, so really just the layer 2 tab you should be familiar with, because it is fair game for them to say like, hey, what tab menu do you click on to get to PSK or something like that. So a lot of people think that just because there's no SIMs there, they can't get you, but they can make sure that they can test around just as effectively. So there's that. You also want to QoS. I would spend, an hour or two or whatever, just making sure you're aware of the basic options. They're not going to ask you to configure like actual contracts and like say like, hey, I need 100K for per, like they're not going to make you do calculations and stuff or any of the link stuff, but they'll ask you what they'll ask you about the types of QoS. So be aware about that. Advanced, they won't ask you anything there. So that's the bare basics. Like if you have an opportunity to do it, I mean, even packet tracers good enough for basic studying. And then I would just maybe just have a gist of what are in the tabs there. Like management is, well, management stuff, so that's pretty straightforward. Commands is the only ambiguous one there, and that's where like you do your firmware upgrades and your reboots and that kind of stuff. Security is your security tab. We looked at adding a radius server. TACX is not an exam, but same idea. The certificates, if you're doing a lab, remember to figure out, you either need to know how to deal with this or you need to turn it off there so they have a happy lab experience. I would make sure you know how APs register for, mostly just so you're labbing, because if you don't know how to actually use your AP, you're not going to get very far. I would be aware of the main differences between local mode and Flex Connect. Basically, local mode is your cap-up tunnel to the WLC, and Flex Connect means you're dropping the traffic directly on the where the AP is. So we didn't get into it, but it basically is configured completely differently. So you need to be aware of that if you're doing a virtual WLC for your lab, because there is no local mode. I think that's basically all the main stuff that you can get. Yeah, I think that's about. I think that's about the gist of it.
Yep.
WLAN. So just make sure you know do the basics. Then just I would just click around in whatever WLC you have access to, and just as a, I mean, even if you guys just want to download the virtual wireless controller, you don't necessarily need access points. You can just play around with the menus and make your own access. You can make your own SSIDs there and just never have the access points to connect them to, and that's a viable option.
Yeah, just to get familiar with the interface.
Yeah, and then I would spend a little bit of time on the interfaces just so you're aware of what they are. So know what a dynamic interface is. That's what we did for SSIDs. Know what the management is, and then just have a vague idea like about the other ones there. Just be aware they exist. And then the service port is the only one that doesn't make a lot of sense. In terms of other things. So that's the only really weird port, but everything else is about the same.
All right, cool.
Yeah.
So yeah, as you said, you can do this in the virtual WLC or even packet tracer. It's very limited, but it allows you to create a basic WLAN, basic SSID with some simple options like PSK. So I think it's good enough to
9800 is 1 sec. Yeah, just booting up now. I'll just give you a quick look at it so you can see the differences there. We'll just leave it there.
Oh, sure.
So
cool.
Yeah, no questions yet?
Nope. No questions in particular. So if you guys are going back and watching this video again to study, definitely look at how he created the guest WLAN, because that's the one using the PSK, pre-shared key authentication. That's the one you really need to focus on for the exam. And then do make sure that you get your own practice either in the VWLC or in packet tracer. Just click around and make a simple WLAN and get familiar with it.
Yeah. It's not too hard. Like Cisco was not expecting you to do command line and stuff. I mean, you could, but and in fact, in my book for where I talk about the wireless there, I show you how to do I probably do it overboard. So I explain all the interfaces and I show how to do things in CLI as well. So pick up Taldamu's book there if you want to know all the little things you need to know.
Yep. If you guys aren't aware, Donald actually helped write the volume 2 of the Todd Lamley CCNA books. So definitely pick that one up if you want to learn about wireless, automation, those new topics like that. And those are the sections that you authored, right? Wireless automation.
Yeah, I wrote, I think it was about 5 chapters. So the back end of the book. So cool. I did the wireless configuration. I did some of the wireless theory, and then I did the automation SDN stuff.
Cool.
Just see, is that almost up? Here. No, my connection's not private. I'm broadcasting it. This is a lot different if you're spent any time on the WLC. So the main thing is like all the configuration is much more modular. So what you can actually do is they have a nice little advanced wizard there where they walk you through how to make your profiles and so on and so forth. Like, so you can see I made Mailcat Wi-Fi as a test. They set all of my settings there. So the GUI is much nicer.
Yeah.
And then very flexible. So what you would do is you make the profiles. You would make your policy for what's allowed and what's not allowed. And then you basically do a concept called tag, where you basically this is how you bind your policies together, and you do like control how the APs are being joined, like schematic site tag, and you would eventually just tag them to the APs that are registered to it. I don't have anything on here right now, but but the actual iOS there is up and running there. So if I go to my secure CRT, I do. So this is the iOS we all know and love. You can do your routes. You can do tunnel interfaces if you want to get fancy. You can do like you can do really fancy stuff there, like VPNs. You can do VXLANs. You can do this. Basically, everything that's in the iOS XE you can work with. This version doesn't have router, but the other one does. But you can, so basically all your standard tricks in iOS is here. So you can do like the show IP interface 3. If you wanted to filter things, you can do like filter on whatever you want to filter on. So so it's much nicer than the whole Air OS kind of thing there, and it's nice having a unified platform, and obviously all the new features are going to be put toward the 9800 eventually, and de-emphasized on the WLC in time. But I just want to quickly show that. Looks a lot nicer and a lot more options, more streamlined, and generally works pretty well. It takes some getting used to for sure, but it's definitely a nice evolution, especially since their competitor Aruba has been a layer 3 controller for ages, and it's nice to be able to do similar things on the 9800 now.
Yeah.
Anyway, that's should be about it. I guess last round of, is there any questions?
One small question. You asked how to do demo with tabs. Are you referring to the CLI, the terminal with tabs? I'm not sure what he means. Yeah, how to do demo with tabs. Maybe the tabs in the CLI. So that's because you're using secure CRT, right? You can use the tabs. Something like PuTTY doesn't have tabs, for example. Yeah.
Oh, yeah. This is natively in secure CRT. It's one of my reasons I like it. You also have session managers, so I can have all my random network devices there, like Network Dojo is where I do my CCA wireless training stuff. But so you can have like nice session sync. You can have automatic logins. It's a great tool. I would recommend it. If you don't want to go all that way, there's also Mobile Xterm that is reasonably good, and it has some similar options there. So I can go like, was it 169? So this has some built-in coloring too, and it has its own strengths and weaknesses. I prefer secure CRT, but this one is a little bit cheaper. I can't remember the exact prices of each, but it's an option. Cisco also makes an SSH client that has some strengths and weaknesses. I'm not a big fan of it, but it has some nice automation features that might be useful. So yeah, there's all kinds of fun session manager stuff you can do.
Cool. I wasn't aware of Cisco's terminal.
I'll show you real quick. What is it called? CLIN, I'll say this. When my clients watches this there, he's going to be happy because I bash his CLI analyzer all the time and demoing it. But this is the Cisco version. Now, the idea of this one is that the idea of this one there is that it has some automation features, so it can go ahead and submit things to TAC for you, and it can do some fancier stuff. So if I open up a session, I'll just call this. And as far as I'm aware, this is free too. You can download this if you want to. You can see this is going ahead and grabbing some things there. But you can see if I wanted to do, say, a packet capture, it can. It's just going to sign into it, but what it'll do is you will talk with get the basically it'll upload stuff to TAC or like a server, and they will figure out what it needs to do. So it's handy if you're doing more of a operational kind of thing. So when it gets logged in, you can see it's just going to walk you through how to configure things. It's grabbing the output, and basically it's going to ask you questions like, hey, what do you want to see, that kind of thing. And so it has some strengths and weaknesses. It falls down when it's not a supported device. Like if you try and connect to like a Cisco server on there, it's going to fall on its face because it's meant for like doing like routing table analysis and that kind of stuff. But it's okay. I mean, it's not my favorite thing in the world, but. All right. Well, anyway, yeah, you get the idea. But
okay.
I don't feel like that's my password again.
All right. I think we can wrap it up there. That was a good demo. All right. Let me change the view back to our cameras. You can end the screen share.
Oh, can I though? Let's see
Can you?
here. Stop sharing. There we go. Confirm.
All right, we're back.
We're back.
All right, thanks for the demo. That was a good overview of the CCNA wireless topics, and then some on top of that. So we got a good look at basic WLC configuration, including a good look at ICE, which I haven't showed you in the course, although I did talk about it briefly. How to set up radius on that. Took a look at Meraki and the new GUI of those 9800s. For the CCNA, you don't have to know that new GUI, right? Just the old classic WLC.
In fact, yeah, it's like even the CCNP barely talks about it there. It's really only when you get to the CCIE lab you need to learn about it from a CERT perspective. I mean, from the real world, yeah, that's a different matter.
Right. This is just a general question, but generally in the industry, like who is the current like leader in wireless? Is that still Cisco?
Oh yeah, Cisco's dominating. I think they're 60-something% of the market for wireless.
Yeah.
Maybe a bit higher. So it's like something like 60 or something like that for Cisco, and I think Aruba is like 20, and then everyone else is sliver.
Yeah. So that Cisco would include Meraki also, right?
Yeah. So Cisco does include Meraki there. So I'd probably be closer to like 40% for like the Cisco core products there. Probably like 20% from Meraki if you didn't have that.
Yeah. Okay, so they're still the dominant leader.
But yeah, they're still definitely on top there. You're more likely to. I don't know. It's a good mix in the real world, but it's definitely worth at least playing with. And in terms of friendliness for labbing and whatnot, Cisco is actually a lot better than Aruba, because Aruba, they like when you download like a WLC, for example, it has trial licensing and stuff that you can play with there. But Aruba, you have to uh, get like 5 separate licenses, and it's a real pain. And if you're not a partner, then good luck with that.
Yeah, yeah. Okay.
And of course, the other vendors are much more niche, but yeah.
Yeah, yeah, yeah. So if you're learning wireless, definitely a good idea to learn the Cisco stuff. That's most in demand, as with pretty much any area of networking.
Yeah,
Cisco's
and
the
with
king.
wireless is probably the only area I'd recommend looking at, like a vendor neutral cert, like the CWNA,
Hmm.
because at least a lot of the RF stuff there, like it's transfer, you can use that for a good foundation. So that's probably the rare case where you can say that a vendor neutral cert is worth it there. I mean, I like to poke at CompTIA for quality of their exams, and they don't really prepare you for much. But the CWNA is something that, even if you don't take the cert, it's worth reading the book there, because it's good foundational knowledge.
Yeah, I'm reading through that now. The official, or I don't know if it's official, but the Cybex guide, and that's got some really good stuff in there about just the basics of RF and how it works.
Yeah, and they go up. They have a bunch of tracks too. There, they go up to their own expert level.
Yeah, yeah,
So there's definitely a lot there. So it's a good supplemental thing if you wanted to get more into wireless. It's definitely a no strings attached field.
oh, the puns. All right, I think we'll end it with that pun there. All right. So
Perfect.
thanks, Donald. Maybe I'll have you on not next month, but sometime next year, January, February. Do another stream.
Yeah, fair enough.
Sure, sounds good. All right, thanks everyone for watching. I hope this was helpful. Definitely go back and watch it again, especially the configuration section to get familiar with how the WLC GUI works. And yeah, if you have any questions, feel free to leave them in the comments, and I'll get back to you. All right, we'll end it there. Thanks, everyone. See you next
Cool.
time.